Let's do section 4.6, exponent laws, the example problems. Example number 1. Simplify by writing as a single power. Explain your reasoning. Now, I'm going to explain my reasoning orally. If you are asked to explain your reasoning on an assessment, you would need to write out why you did each step. All right, let's take a look at letter A. 0.8 squared times 0.8 to the 7. We are using multiplying a power by another power. The base is 0.8, so we have the same base in both of them. So we just need to add the exponents. So this can become 0.8 to the 9th power. We use multiplying a power by another power. Letter B. Let's identify our bases. Our base is negative 4 over 5. Our base here is negative 4 over 5. So we've got some bases that are the same. Now, the first thing that I'm going to do is I'm going to do power to a power for both of them. I'm going to simplify both of them separately by using power to a power. So our first one is going to be negative 4 over 5 to the power of negative 6 times, because there's no sign between the parentheses there, it is just multiplying. Our second will be negative 4 over 5 to the power of negative 20. So our first step was power raised to a power. Now we're multiplying two powers of the same base, so we're going to add the exponents. So we're going to have negative 4 over 5, and we add negative 6 and negative 20 to get negative 26. All right, now, I don't like having powers with negative exponents as an answer, so we're going to turn this into a positive exponent. So to do that, we just take the reciprocal. Negative 5 over 4 to the power of 26. There we go. That is simplified as much as possible. All right, let's look at letter C. We have a base here of 1.5. Now, whenever we have a fraction like this, we want to simplify the numerator as much as possible. Then we can work with the power divided by a power. So let's simplify this numerator. We've got a power raised to a power, so we multiply the exponents. We're going to get 1.5 to the power of 15 divided by 1.5 to the power of 5. Now we have a power divided by a power, so we subtract the exponents. So it's going to be 1.5 to the power of 10. And that is our final answer. Letter D. We have another fractional one. This time our base is 9. And we want to simplify the numerator first because there's some multiplication going on in the numerator. So to simplify the numerator, here's what we do. It's a power times a power. So we're going to add the exponents. So 5/4 plus negative 1/4 gives us 9 to the power of 4 over 4. We're dividing that by 9 to the power of 3 over 4. Right, we can just add fractions like we normally add fractions. Now we have a power divided by a power. So we're going to subtract the exponents. So we're going to do 4 over 4, take away 3 over 4, which is equal to 1 over 4. So our final answer is going to be 9 to the power of 1 over 4. And that's our question simplified as far as possible. All right, let's take a look on example 2. Now we're going to get into some variables, and I'm going to do things the long way. There are some shortcuts that you can work on. I'll show you some in both methods. All right, first one. This one is a number with m to the power of 4 times n to the minus 2, and then multiplied by another number. So everything's just getting multiplied here. I can rewrite this as m to the power of 4 times m to the power of 2 times n to the power of minus 2 times n to the power of 3. So for my m's, I'm just going to combine them using power multiplied by a power, so I add the exponents, m to the power 6. Then I multiply the n's together. It's power multiplied by another power, so we just add the exponents together, n to the power of 1. Now, a power of 1 I don't need to include. I can just rewrite this as m to the 6 times n. All right, letter B. We've got this fraction thing. Everything in the numerator is being multiplied. Everything in the denominator is being multiplied. So we can separate this fraction into 3 multiplication questions. Our first one is 6 over 14 times x to the power of 4 over x times y to the power of minus 3 over y squared. All right, our first fraction, 6 over 14, that simplifies to 3 over 7 times x to the power of 4 divided by x is equal to x to the power of 3 times. Now we've got another power divided by a power, so that is going to be, so we do negative 3, subtract 2, and we're going to get y to the power of negative 5. Negative 3 subtract 2 is negative 5. Now, I don't like having that guy there with I don't like having this guy here with a negative exponent in it, so I'm going to turn that into a positive exponent. Times x cubed times 1 over y to the 5. Now, I'm going to combine all this together into one fraction again. X to the power of 3 is the same thing as x to the power of 3 over 1. So I multiply my top out, and I get 3x to the power of 3 over 7y to the power of 5. All right, now I'm going to show you this question doing it a different way. 6 over 14, x to the power of 4 over x, y to the power of minus 3 over y squared. All right. So this negative tells me to swap that y to the minus 3 to the other side of the fraction. So since this is on the numerator, I swap it down to the denominator. And I get 6 over 14, x to the power of 4 over x, and y to the squared times y cubed. Same thing. Now, I just simplify my fraction first. Everything's multiplied in the numerator and the denominator, so I can just do this. So I get 3 over 7. Now, I've got 4 x's multiplied together in the numerator and 1 x in the denominator. So my 1x is going to cancel out one of those x's in the numerator, and I'm going to be left with x to the power of 3. My 1x cancels out one of those x's. I'm left with x to the power of 3 in the numerator. And in the denominator, I just add my exponents together because this is a power times the power, and we get y to the power of 5. Same answer, 2 different methods. All right, so let's take a look at example number 3. Simplify. Again, explain your reasoning. I'm explaining it to you orally. Now we have a whole term multiplied together. So a single term, everything's multiplied together. So we can take this power and multiply it by each one of these terms. So we're going to get 25 to the power of 3 over 2 times a. Now what's 4 times 3 over 2? So let's just take a look over here. 4 times 3 over 2. Well, that's equal to 12 over 2, which is equal to 6. So it's a to the power of 6. And b, well, what's 2 times 3 over 2? Well, it's equal to 6 over 2, which is equal to 3. So b to the power of 3. Now, I've simplified it, but I can simplify it even farther because this is pretty easy to work with. Right, our 2 in the denominator is the square root. So I can take the square root of 25, and I get 5 to the power of 3. A to the 6, b cubed. 5 to the power of 3 is pretty simple. It's 125. a to the power of 6, b to the power of 3. You should have some of the perfect cubes and perfect squares memorized by now, and you should be able to use them quickly. So there's my thing simplified. Letter B. My first term is all multiplication. My second term is all multiplication. I'm multiplying them together. It's all multiplication, so I can multiply in any order I want. I can rearrange the terms in a multiplication question into any order I want. So I do x to the power of 3 times x to the power of minus 1 times y to the negative 3 over 2 times y to the power of 1 over 2. Now let's see what we get. We have power multiplied by a power, so we add the exponents. So we get x squared. And we have another power times a power, so we add the exponents. Well, what's negative 3 over 2 plus 1 over 2? Well, it's equal to, I don't want to write that equal sign there, y to the power of negative 2 over 2, which is the same thing as negative 1. So it's equal to x squared times y to the negative 1. Now, I don't like you having negative exponents in your simplified answer, so we're going to turn this into a positive exponent. It's equal to x squared times 1 over y to the power of 1. I don't need to write that 1 in. Now I can combine these two together to get x squared divided by y. Some basic algebra manipulation. All right, let's keep going. Letter C. Letter C is it's getting pretty complicated. 12x to the minus 5, y to the 5 over 2, over 3x to the 1/2, y to the negative 1/2. I'm going to break this apart into 3 separate fractions. 12 over 3 is my first one, times x to the minus 5 over x to the 1/2, times y to the 5 over 2, divided by y to the minus 1/2. To me, in this case, in this one, this is the easiest way to do this one. All right, my first fraction simplifies down into 4. Second, it's a power divided by a power, so I subtract the exponents. Well, it's negative 5, subtract 1/2. X to the negative 11 over 2. Negative 5 subtract 1/2 is negative 11 over 2. Times y, and we do 5 over 2 divided by negative 1 over 2. So we're going to subtract the exponents again. So 5 over 2 subtract negative 1/2 is going to be 6 over 2. Okay. Now, I don't like this guy right here with the negative. So I'm going to rewrite that guy out so it has a positive exponent. A negative just tells me to take the reciprocal. So I can just do 1 over x to the power of 11 over 2 times y to the power of 3. And I can combine everything together now. 4 is the same thing as 4 over 1, and y cubed is the same thing as y cubed over 1. And just multiply them out. So 4y cubed is on the numerator, and we have x to the 11 over 2 in the denominator. All right, and that is simplified. In this simplification process, I broke everything. I broke the fractions apart. This next one, I'm not going to break the fractions apart. I'm going to work it all together. All right, so in this one, I want to simplify everything in the parentheses first before I do the power outside the parentheses. All right, so here's how I'm going to do this. I'm still going to have my fractional line. 50, we'll work with the 50 over 2. 50 divided by 2 is 25 over 1. So I just simplified the fraction 25 over 1. Now I don't need to write that 1 on the bottom. It will just be assumed. Next thing, going to work with an x squared over x to the 4. We have more x's on the bottom than we do on the top. We have 2 more x's on the bottom than we do on the top. So we're going to be left with, once we cancel those out, we're going to be left with 2 x's in the denominator. To kind of see how that works, there's more x's on the bottom than there are on the top. There's more x's in the denominator than there are on the top. So when we cancel them out, we'll be left with 2 x's in the denominator, no x's left on top. This only works if all your exponents are positive. Let's look at this next one. We have more y's on the bottom than we do on the top. We've got 4 y's multiplied together in the numerator, and we have 7 y's multiplied together in the denominator. When we simplify that out, we're going to be left with 3 y's in the denominator. Now you see why you can only do this with positive exponents. If you have negative exponents or fractional exponents, you can't really do this. But if all the exponents of all the variables are positive, you can just work this question like this. Now, we've still got this 1/2 on the outside. All right. Now, this 1/2 is going to get distributed to every term in the numerator and every one in the denominator. We're going to multiply it. We're going to put it multiply the exponents of everything by it. So we're going to get 25 to the power of 1/2. X squared, and we do the 2 times 1/2 is x to the power of 1. That's 2 times 1/2. And y to the power of 3/2, because that's 3 times 1/2. Now we can simplify this a little bit further, because 25 to the power of 1/2 is easy to figure out, because that's just the square root of 25. So we get 5 over x times y to the power of 3/2. That is our answer, simplified as possible. All right. You can see how there's 2 ways to do this type of question. Way 1, break it up, and you do this if it's got negative exponents or fractional exponents. If all the exponents are positive numbers in the numerator and the denominator for all the variables, you can just simply kind of cancel out like I did in letter D. Example number 4. A cone has a height and a radius with a height and radius equal, has a volume of 18 centimeters cubed. What are the radius and the height of the cone to the nearest 1/10 of a centimeter? Got a problem? Let's sketch it out. We've got a cone. There's my cone. It's got a radius, that's r, and it's got a height, that's h. And h and r are equal, so we can call them both r if we want. We have the volume of a cone. The volume of a cone is equal to, if I remember right, we do pi times the radius squared times the height divided by 3. Now, in this volume, there's 2 variables. But in our cone, we just said that the height and the radius are equal. So we can rewrite our volume question like this. Pi radius squared times radius divided by 3. Now we only have 1 variable in our question because we know the volume. So let's replace the volume with what we know. 18 is equal to pi times radius cubed divided by 3. Now we need to solve for our radius. To do that, I need to get rid of that 3 from the denominator. So I multiply this side by 3, and I multiply this side by 3. And 18 times 3 is 54. Pi r cubed. Now, I have to eliminate this pi to get my radius by itself. So I'm going to divide this side by pi and divide this side by pi. These will cancel out. And my radius cubed is equal to 54 divided by pi. Keeping this as an exact value right now. Now lastly, to cancel out my cube root, I'm going to cube root both sides. Cube root both sides is equal to r is equal to the cube root of 54 over pi. And that'll be centimeters. That is our exact value. But the question's asking for the nearest tenth of a centimeter. So we're going to go to a calculator and try and figure this out. I'm going to try Microsoft Math again, which you can download for free and use. So Microsoft Math. We're going to see if this works. I have my pencil on. I'm going to draw it. The cube root of 54 divided by pi. Let's see if it interprets this. It gave us that interpretation right there and gave us the answer. It's equal to 2.58. So you can download Microsoft Math. It'll help you learn math a little bit. If you click on this, it'll show you how it evaluated it. And it will show you some videos that are related to this. Simplifying square roots of fractions from Khan Academy. Some related concepts, some worksheets, and similar problems from the web. So they'll give you some other information on it. So 2.58 is our answer. .88? Nope. 2.58. And that's in centimeters. That is the approximate value of our answer. All right, if you have any questions, please put them in the comments.